And then I consider this area, this region. Okay, what I'm going to do is I'm going to rotate this one by 360 degrees. So it is as if this is the hinge of the door, and I'm gonna turn this door 300, a revolving door, 360 degrees, and it's going to sweep out a region, and that region will look like this. This is z-axis, and it's going to be like this. All right? Right? Okay? And then, so here is the original position of the door. It is, that one. But then you imagine there, turn it 360 degrees, sweeps out a solid region. And then the question is that what is the volume of that region? What is the volume of that region? Okay? So we're going to use the same trick. This kind of problem, in section 2, our general strategy would be as follows. We're going to make cuts, all right? And we're going to take a strategy very similar to the strategy I just used to deal with this spherical ball. So I'm going to make a cut. I'm going to have a horizontal plane which is perpendicular to the axis of rotation, axis of symmetry. So because this is vertical, V is vertical, and therefore the plane will be supposed to be horizontal. And then I'm going to use Z to control it, control the position. Z is a height, right? So I start at the bottom. Then it only touches on this vertex here, right? And then as I gradually bring it up, it begins to cut through, right, a finite cross-sectional region. And then if I keep rising, if we keep raising it up, then the cross-sectional region is going to grow. And how do you characterize that? How do you verbally describe a cross-sectional region? Would you agree that it is a what? Circular disc, right? All right. So here's a typical one. Here's a typical one. Once you raise this one to this height, then it's going to cut through something like this. Correct? All right. Now, at a certain height, well, actually, I call that Z. I should have called it what? Y. Sorry, to be consistent with that. Okay, so this is Y. This is Y. And then C should be in this direction. So changes to Y. And so I'm going to use Y to capture the height. All right? So Y is going to go, so let me go over here. It's pretty much the same kind of idea. So I'm going to say Y goes from 0 to the highest point, which is Y equal to what? 4. For a typical Y such as this one, I would have a what? Horizontal area, correct? And that I'm going to call A. A depends upon what? Y. So that's just the area. But then remember, just like before, I imagine that I push this scan plane from the lowest position to the highest position. I'm going to stop at 999 places, for example. Right? And then, so essentially I make 999 cuts to create 1,000 little pieces, for example. Anyway, large number of cuts. And so you're going to have a lot of very thin slices, and a typical one has a certain area, right? And then also thickness. What is thickness? dy. dy. And now I'm set. Y from 0 to Y to 4. And this is pi times the area, sorry, not area, the radius, which depends upon Y, and then squared, right? and times dy. Now the question is that what is that radius? So what is r of y? Well, that comes from, you see, if you go here, you know, that circular region results from, see, here's the typical y value. And then see this line segment in this shaded area. As it is rotated, this line segment is going to sweep out exactly that disk, correct? So what is this point? This point says you have the x and y, and this x, y satisfy this, is that right? Okay, so what I want really is that this will be the radius, and that radius would be exactly this x coordinate, correct? So that will be x. So the radius really is x. Pi times square radius. Radius is nothing other than x. Squared dy. Right? But bear in mind that when I write x, I have in mind that that x is controlled by y, so you really can express it in terms of y. But that's what that equation is about. Y equal to what? X squared. X squared is y. Right? So therefore we have pi what? Y dy. Right? And then I'm done. This is what? Pi over 2 y squared. Y goes from 0 to 4, and therefore it's 8 pi. Get the idea? Okay, again, it's just imagine that you make large number of slices, and then in setting up the integral, you ask yourself, okay, in which way I mean, what's the orientation of the horizontal cuts, right? You know,